NVIDIA just dropped an open-weight 550 billion parameter reasoning model that runs at over 300 tokens per second. The training data is mostly open too, and the architecture is half Mamba, half Transformer, with multi-token prediction stapled on. Yeah, this one's a lot. Okay, so Nemotron 3 Ultra, released June 4th, 2026, 550 billion total parameters, 55 billion active per token, which means it's a mixture of experts that only fires about 10% of itself on any given forward pass. 4 checkpoints shipped on the same day: the NVFP4 quantized build, a BF16 instruct model, a BF16 base, and a separate generative reward model variant for people building their own RL loops, all under the OpenMDW 1.1 license, which is basically Apache 2.0 with extra Linux Foundation stewardship. This is the third drop in the Nemotron 3 family. Nano came out in December, Super came out at GTC in March. Ultra is the big one, the capstone, the one that's supposed to actually compete with frontier models. And the headline number is 48 on the Artificial Analysis Intelligence Index, which makes it the best US open-weight model that exists right now. Beats GPT OSS 120B. Beats QN 3.5, sits about 6 points behind Kimi K2.6, which still owns the global open-weight crown. Low-key embarrassing for Team America that the Chinese open models are still ahead, but Ultra closes a lot of that gap. So how does it actually work? There are like 4 interlocking ideas here, and they all matter. First, Hybrid Mamba Transformer MoE. The model is not a regular transformer stack. It interleaves Mamba 2 state space layers with selective attention layers, with mixture of experts feed-forward blocks in between. Mamba 2 is the linear time state space architecture from Tri-DAO and Albert Gu, the one where the memory cost stays constant as your context grows. Attention is quadratic. Mamba is linear. The hybrid takes the best of both. You get the recall of attention where it matters, and the throughput of Mamba where it doesn't. The reason this is such a big deal at 1 million tokens of context is that pure attention at that length would melt your GPU. Mamba sits underneath doing the heavy lifting, and attention layers selectively get inserted where the model actually needs to do random access lookups. That's how Ultra hits 94.2% on Ruler at 256K. For comparison, GPT OSS 120 billion gets 88.7. Qwen 3.5 gets 89.1. Long context isn't just a marketing number here. It actually retrieves First Septurion Detective Edition and GPT-KS. Second, latent MoE. This is the novel bit. Standard granular MoE, the kind DeepSeek uses, routes tokens to fine-grained experts directly in the model dimension. Latent MoE routes in a compressed latent space first, so you get the parameter efficiency of fine-grained experts without the routing overhead exploding. NVIDIA claims better accuracy per parameter than standard granular MoE. The numbers in the technical report back this up. MMLU Pro climbed from 64.8 to 66.6 just from this swap. GPQA went from 30.8 to 41.9. That's like an 11-point absolute jump on a reasoning benchmark from an architecture change, which is kinda insane. Third, multi-token prediction, borrowed from the DeepMind paper by Global et al. Instead of training the model to predict only the next token, you train it to predict the next few tokens in parallel. At inference time, those extra prediction heads become a speculative decoder. You generate 3 to 5 candidate tokens at once, verify them in a single forward pass. If they match, you keep them all. If they don't, you fall back. The end result is somewhere between 2 and 5 times more tokens per second, depending on how predictable your text is. Combine MTP with the Mamba hybrid throughput, with NVFP4 quantization on Blackwell GPUs, and you get the 300 tokens per second number on a 4 GPU B200 box. For comparison, Qwen 3.5122 billion does about 40 tokens per second on the same hardware. That's not a marginal speedup, that's 7.5 times. Fourth, NVFP4 training, not just inference. Training. NVIDIA pre-trained the entire base model in 4-bit floating point on 20 trillion text tokens. 2 phases. 15 trillion tokens of diverse pre-training, then 5 trillion tokens of high-quality refinement. Doing 4-bit pre-training at this scale, on this much data, with the final model not collapsing, is the kind of engineering flex that makes other labs nervous. Most people are still doing BF16 pre-training and quantizing after. NVIDIA just skipped that step. Post-training is multi-environment reinforcement learning. Instead of one big RLHF pass, they trained more than 10 domain-specialized teacher models, each on a targeted recipe. then unified RL with verifiable rewards across reasoning, agentic, code, safety, usability, and chat environments. The model has a granular reasoning budget control, so you can dial up or down how long it thinks. Same setup as the chat template flag on Qwen 3. Okay, let's talk numbers. Human eval for coding, 92.1%. GPT OSS, 120 billion, sits at 87.3. Qwen 3.5 at 88.6. MMLU, 89.4. Same comparisons, Nemotron is ahead. Ruler at 256K, 94.2. Pinchbench agent productivity, basically tied with Kimi K2, 6 at 91. So, where's the trap? Couple places. The 1 million token context is architectural, not always served. Most deployment configs cap at 262K. If you want the full 1 million, you have to flip a long context flag, and you'll need a lot more memory. Also, Ultra is currently Blackwell only. The model card explicitly says Hopper support is planned but not available, which is convenient for NVIDIA's hardware sales and inconvenient for everyone with H100. Also, the headline 300 tokens per second is measured with MTP speculative decoding turned on in NVFP4 on B200. Drop any of those and the number falls. On 8x H100 in BF16, you're looking at something more like 50 to 80 tokens per second. Still fast, but not the marketing number. What changes from here? A lot. For enterprise teams, this is the first US open-weight model where the gap to frontier closed enough that you can seriously self-host instead of paying API rent. The OpenMDW license is genuinely permissive. The weights are real, the training recipes are published, even most of the post-training data is released. Compare that to Llama, where you get weights and a paragraph. This is open in the way the original GPT-2 release was open. For other model labs, the latent MoE result puts pressure on the standard granular MoE setup that DeepSeek and Qwen use. If you can get 11 GPQA points from rearranging your router, expect every other lab to be writing papers on latent space routing by August. For consumers, this changes basically nothing in the short term. You're not running a 550 billion model on a 3090, but it changes a lot indirectly. The companies that serve you AI through APIs and apps and agents are all looking at Ultra and asking, do I need to keep paying OpenAI when an open model is this close? For NVIDIA, this is the strategy reveal. They are not just selling shovels in the gold rush. They are also dropping the best open shovel and saying, here, free, just buy our hardware to run it. The Blackwell exclusivity at launch is not a coincidence. For caveats, the intelligence index of 48 is one number from one benchmark, and Kimi K2.6 still scores 54. NVIDIA is not the open weight king, just the US one. The training data being open is partial. The post-training data is permissive. The full pre-training corpus is gated to researchers. The model is also genuinely huge. Even at MoE sparsity, you need 4 Blackwells minimum. This is not the kind of thing you fine-tune on a weekend. Honestly though, the thing that matters most about this release is not the benchmark, it's the architecture choices. Hybrid Mamba Transformer is real now. Latent MoE works. NVFP4 pre-training works. Multi-token prediction works. NVIDIA stacked 4 bleeding-edge research ideas into one model at frontier scale, and it actually shipped. The era of pure dense transformers is closing. If you would like to hear and see the latest news about LLMs, then like and subscribe.